Hello guys, in this video I will demonstrate how to perform multivariate time series prediction with LSTM for predict future Google stock prices. The main idea is open stock price is a result of multiple different features that can impact our predictions. The problem we will solve is to predict future stock prices based on historical data. Prediction will start on the next day of historical dataset and we will predict future stock price for defined period, let's say for the next 20 days. So we have part number 1, part number 2 and part number 3. And part number 1 is data pre-processing, part number 2 is create a model and train it, part number 3 is make future predictions. And please remember, many different features make impact to the actual price. Let's take a quick look to raw data. I have downloaded a dataset with Google stock prices from official Yahoo Finance website for this demonstration. As usual, when analyzing stock prices, we have such default features: open price, high price, low price, close price, adjusted price, and volume. The value we want to predict is open price for the next day. This value can be impacted by rest of features, right? Let's make this assumption for this tutorial. Please be noticed that the implementation algorithm demonstrated in this tutorial can be adopted to any real-life multivariate time series problem by including LSTM. So, let's come back to the scope and download the data we will work with in this tutorial. My special message to you. With this video tutorial I want to demonstrate how to perform multivariate time series prediction with LSTM. I will not go into mathematical details behind, just how to implement the idea in Python. I'm not finance expert, so the demonstrated model could not be very accuracy. This is just a demonstration of style how to do. Use deep learning versions. TensorFlow is 1.15.0 and Keras is 2.3.1. I assume that you have experience in Python programming and some practical experience in machine learning and deep learning. This video has 3 parts. Part number 1 is data pre-processing. Part number 2 is create a model and train it. Part number 3 is make future predictions. So part number 1 consists of 3 steps. Step number 0, fire the system when we import all basic Python libraries for starting with the data. Step number 1 is read the data. Step number 2, data pre-processing. It is a shaping and transformation of data. In part number 2 we have step number 3 and step number 4. Step number 3 is building up the LSTM based neural network, and step number 4 is start training. Part number 3 has steps number 5 and step number 6, and step number 5 is make prediction for future date, and step number 6 is visualize the predictions. So, welcome to the part number 1. What we will do? We will fire the system, we will import all required libraries to the model, and we will read the original data. It is a stock prices CSV file, and we will make a data shaping and transformation that will work with LSTM in part number 2. So let's do it. We begin our project with step number 0. It is a fire the system. In this step we will import all basic modules and packages that we will use in our project. NumPy for numerical calculation, Matplotlib for data visualization, RCparams for controlling our plottings in our notebook, datetime is for timestamp manipulations, pandas for data structuring, and also we will import keras callbacks for controlling our training procedures. When we have imported all necessary libraries to our notebook, we have to load the data to our notebook. In this step, we load the data to our notebook. It is a Google stock price CSV file. And then we select features that should be involved to our training and prediction procedures. It is a columns from 1 to 6. And then we extract dates that we will use in visualization. The idea for this is the Python should understand that we have a timestamp, not just simple strings, but a timestamp for visualizations. And for this we are using datetime library. In the end of this step, we output some basic information about our data. So we have 4006 records in our database and 7 columns. Let's say it's our features, and we have features selected for our modeling. It's a open, high, low, close price and adjustive close price. In step number 2, we'll perform data preprocessing. We remove all commas and convert data to a matrix shape format. In the very beginning, we should be sure that our column names has a string format. Then we have to remove all commas from column names. For this, we will iterate through each columns to remove the commas. After this, we have to be sure that our dataset has a float format. It is necessary to make a numerical calculation, numerical computation, training, transforming, and all numerical functions. Then we have to reshape our dataset as a matrix. And that means that our dataset should have columns, it is a features or predictors, and rows. It is a matrix. Then we have print some information, and we see that we have 4006 rows and 5 features in our dataset. And we have the situation, and always we have a situation that different features or different predictors has different measurements. That means that one feature can be vary from 0 to, let's say, 100, and second feature can vary from minus 50 to minus 25. In order to make in one single scaling, we should use a standard scaler, and we make a scaling for all features that should be used as predictors and for open prices that we want to predict. So one standard scaler for all independent variables and one standard scaler for dependent variables. It is open prices that we want to predict. And the last action that we will make in this step is creating a data structure with time step and one output. Okay, in the very beginning of this action, we have to define xtrain and itrain list where we storage our data for training. Also, we have to define days for future that we want to make a prediction, past days that our neural network will be taken into consideration to make a prediction. So, and future, let's say it will be 60 days. We will want to make a prediction for the next 60 days. Okay. And I think for this prediction, 90 days from history, from historical data should be enough. I don't know, but let's try to do it. Okay, and past it is a 90. And then we append the values to xtrain and itrain. Then we should convert the data to numpy arrays. So xtrain and itrain is a numpy arrays, different numpy arrays, and it should have a shape. Xtrain is 3857 records and 90 days from historical data and 4 features. That's our predictors. And iTrain has a shape 3857 rows and only one features. It is an open price. It is the value that we want to predict. We have just finished the part number 1, so welcome to the part number 2. In this part, we will create a model and training. So we will make a LSTM based neural network and we'll start training based on defined hyperparameters for the neural network. Welcome to the part number 2. In this part, we will create a LSTM-based neural network and will train it with our training dataset generated in previous part. Firstly, import all Keras modules that are required to build the neural network that we want. So, sequential, dense, LSTM, dropout, and one of optimizer package should be added. I decided to choose Adam as optimizer, just for try. Now we are ready to build a simple neural network with LSTM. As always, start building up a new neural network by defining it should be as sequential. I decided to choose 64 nodes in the first LSTM layer. Take a look in input shape parameters, where get shape values from our dataset. It is important if you have multiple features for prediction, not only a single one. The second LSTM layer will consist only of 10 nodes. Let's do like this, and we will see what's happened. In order to avoid overfitting effect, let's include a dropout at the end with the level of 0.25. Last layer, as always, is dense, with only one output unit, because we want to predict only one value, it is open stock price. Now the structure of our network is done. I don't know how accurately it will work, but let's see. So we are ready to compile our neural network with Adam Optimizer. I decided to set learning rate to 0.01 and loss function to mean square error. In step number 4, we are ready to start training. When we have defined the structure of our neural network, we are ready to start training. I think it will take a couple of minutes for such amount of data we are having. In order to not waste time in training while the accuracy not increasing, we defined early stopping alert. Here we have parameters such as monitor, it is a quantity to be monitored. Minimum delta is a minimum change in the monitored quantity to qualify as an improvement. Patience, it is a number of epochs with no improvements after which training will be stopped. Let's set a TensorBoard logs parameter, maybe we will use it. And lastly, that's the moment we have waited for. Start training on our training dataset, xtrain and itrain. You will see a real-time result for each epoch below. For this training I use only 10 epochs. Batch size is 256, I decided it randomly. So take a look into training. We have just finished the most important part of this tutorial, and welcome to the last part. It is a make future predictions. In this part we will make prediction for future date. I think that you have been waiting for this part. And we will visualize the prediction to be sure that our prediction is in the context based on the scope. So let's do it. Welcome to the part number 3, make future predictions. In this part we start with step number 5. Here we will make a prediction for future dates. First of all, we define a list of dates representing period for which we will make predictions. That is variable data list feature. Remember that we have data list train variable from the very beginning, and we are using it here. Then simply convert pandas timestamp to datetime object. It will let us to make prediction visualization correctly on the same timeline as historical data. Now it's a funny part. Let's make future prediction that we are talking about from the very beginning. model, predict, and that's it. Knowing the fact that we are working on scaled training data and our prediction has been made on scaled data, we want to inverse such prediction to original units as it was provided in original dataset. We will do it by using scikit-learn inverse method. In order to have a nice and structured result table, we build a simple pandas data frame with our predictions. Please take your attention to data frame index. It is recommended that it should be timestamped if you are going to work with several data frames in the same timelines. Let's look how it looks like. It seems that it looks good and we are ready to visualize data now. Finally, we have step number 6, visualize the predictions. This is the last part of our tutorial. We will plot our prediction as well as historical data on the same timeline. Firstly, let's define the size of the plot we are going to generate. Secondly, let's define a date that we will start our graph. It's like starting position of plotting. And finally, we will use a standard matplotlib methods to plot our results. Take special attention when defining the period of plotting the data. For this, we are using a start date for plotting variable. And as I mentioned it before, for x-axis it is timeline. We will use a data frame index field. For y-axis it's our predictions, open columns from our data frame. Draw a vertical line to better representing the starting date for predictions. Let's put the gray grid on the top to make visualization more readable. Add legend. Label for x-axis, label for y-axis, style for text on horizontal axis, and that's it. That's almost all for this tutorial, and I just want to tell you that some parts of my code can be improved and full project can be organized in a better manner. But my goal was to introduce the way I perform multivariate time series prediction implementation with LSTM as I do in very clean manner, without any unnecessary off topics. Additional features to the project will be added in my next videos. Please subscribe me to get it first, and write your ideas to the video comments. Okay, looking good. And now I want to add one more line to our visualization. It is predicted values for our training set, not for future. Why? I want to understand how my model performed during the training. I will make the extra prediction for training period in the same way I did for future prediction by using scikit-learn predict method and the structuring data to pandas data frame. And finally, put the values on the same graph as our historical data and predictions. Be sure the timestamp values are formatted correctly in pandas data frame. And as it was recommended, set timestamp values on data frame index field. So that's our results. Feel free to improve the model as you want. I think that good idea in the scope would be to add more features from our stocks, from example Tesla, Yahoo, etc. and grab all those features into one model to make the original data more complex and robust to get more accurate results. In our tutorial, we get a result that the accuracy is less or more good, but at the end of our prediction is getting worse because standard variation in original dataset is increasing. That's all what I wanted to show you today. Thank you for watching. Write your ideas below what you want to see related to this project or to any another topic in data science. See you in the next my videos. Never stop learning. Bye bye.